Hi everyone, hope you're doing okay. I'm still here in the park and I'm going to do a quick walkthrough of this handout right here, which is Organic Synthesis 2. So if you have tried this out, I'm going to give you a few of the answers for it. This one is unusual in that all of these are only one step. So it only takes one step to do number one step to do number two, one step to do number three. So I'm going to draw the picture of each compound, and then we'll just run through the types of reactions that we're talking about. So number one says we're starting with this 3-ethyl pentane. We want to make 3-ethyl 1-fluoropentane. That would be something like this. Of course, we know what that is. Gotta be. The only thing you can do with an alkane is free radical chain reaction. Number two, we're turning that into pentanol, like so. That sounds like SN2. So far, so good. Number three says pentanal. You might remember that al is the ending for aldehyde. So that one looks like that. If you want to throw on an H down here at the bottom, you can, but you don't have to. So that would be gentle oxidation for number three. Number four, we're converting it to the acid. So yoink, basically like this. That would, of course, be powerful oxidation. Number five, now we start getting into funky ones. Methyl 3-ethyl 1-pentanoate. So that is the methyl ester of 3-ethyl 1-pentanoic acid. So if we are making this into an ester, and it's the methyl ester, we know that when we make esters out of acids and alcohols, that is Fischer esterification. So this, first of all, is what that thing is, methyl 3-ethyl 1-pentanoate, that methyl ester. And we know that this, of course, must be our good buddy Fischer esterification. Hooray. Number six is another funky one. We're going from one ester to another ester. That's not a reaction we talked a lot about, but it might have been a reaction that you and your biodiesel group talked a lot about, because the reaction from going from one ester to a different ester is called trans esterification, right? So that is trans esterification. Trans-esterification is the biodiesel reaction. This is not biodiesel because we're not starting with a triglyceride, but going from one to the other, if you add isopropanol to this, isopropanol will swap places with that other alcohol and you'll get that one. All right, number seven says convert this into sodium 3-ethyl 1-pentanoate. That is the sodium soap. So how do we make soap? That, of course, if you're checking your free gift, is saponification. So here's the molecule we're looking at, and number seven is saponification. If we flip over to the back, number eight, we're going to convert that into 3-ethyl 1-pentanoic acid. That's essentially just taking this salt and converting it back into the carboxylic acid. You do that by adding any acid. You can just write H+. On your sheet, that one is known as detergent acidification. I gotta tell you, these three are pretty dang funky, and we don't use them a whole lot. So if you're like, I really had trouble with these, right? That's okay. Don't worry too much about those. Those are some very specialized reactions. The rest of them, though, you should be pretty familiar with. Let's continue on. Now we want to go from 8 to 9. We basically want to convert this back to the alcohol. So that, of course, is reduction, and we need some powerful reduction with lithium aluminum hydride to accomplish that. For number 10, we're converting that into the corresponding bromide, like that one, of course. That would be our good buddy SN2 for number 10, with HBr, not just Br minus, but HBr. Number 11, we're converting that back to the alcohol. Okay, so that's more SN2, right? We're just playing musical doodahs here. I'm getting tired. How about you? Number 12 says we're going to convert that into 5-ethyl 2-methyl 2-hept. What? That is. First, I have to draw this. So if you looked at 12 and you were like, I don't even know what that is, let's draw that. So first, for number 12, says it's. We're going to. We're talking about. Which one are we talking about? We're talking about number 11. I messed this all up. Okay, let's go back to number 8 was good. Number 9, I skipped one of these. Number 9 said convert your into pentanol. Yep, we did that, right? This one was the pentanol for number 9. Check. Number 10, we did that. Check, was SN2. Okay, so here we go. Yeah, so this is number 11. I put in SN2 twice there. For number 11, sorry, here we go. Number 11. I'm not going to redo this because I wrote all that already. Number 11, we're going to convert this into a heptanol. So that's wacky. Let's see if we can't draw out what this is. So heptanol is 7. So I got 1, 2, 3, 4, 5, 6, 7. 7, and it's a 2-heptanol, which is here, and there's also a 2-methyl, which is here, and 5-ethyl, which is here. So somehow we got it to here, right? So if you'll remember, a second ago we just had yoink this, and then we added this whole new group right here. Okay, if we're adding carbon-carbon bonds, that signals to us that this must be Grignard, right? And how convenient, because this was a haloalkane. So that means number 11 must be a Grignard. All right, we know we had to add magnesium to this to make this MGBR. And what was this up here, right? How many carbons did we add? I'm counting now, awesome. It looks like 3 carbons. Plus this jobber right here, right? That became an alcohol. So that implies to me what we added was this, which is a super funky way of drawing propanone or acetone. So this is what we added. So this happened, this fell off, this became an alcohol, bam. So this is the product for number 11, which was Grignard. For 12, now we're making that into a heptene. Right? So heptene means we're going from an alcohol to an alkene. That means E1 if we treat this with acid. We will eliminate this. Zaitsev's rule says this is the most likely product right here. All right, check and double check. We're going to 13. Oh, now 13 we've lost some carbons again. We're back to a pentanoic acid, right? So breaking double bonds means we're going to chop that off. That sounds to me like alkene oxidation, the hot acid kind. So if we do hot acid for this whole piece goes away and becomes its own little oxidized dealie. And here we're left with that. All right, 14. Now we want to go back to the alcohol. So if we have acid and we're going to alcohol, that is a reduction. Again, the powerful kind. Powerful reduction. 15 says we're now converting that into the chloride. That must be SN2, adding HCl. Almost done. 16 is 3-ethylpentane. Oh, now this is a tough one. Normally, when we're removing something like a halogen, removing something implies elimination. But the issue here is this is what sort of halogen? It is primary. And under what circumstances can you eliminate a halogen that's primary? And the answer is none that we've talked about, right? So we cannot do, this is not elimination. We did talk about one other reaction that pulls off primary halogens, and that would be our good buddy Grignard. Remember, there's one flavor of Grignard where you add water. So this one is actually Grignard. You would make the Grignard reagent and then add water. Grignard. Voila. Now we're almost done. 12 says convert to carbon dioxide and water vapor. So if we have a hydrocarbon, how do we convert it to carbon dioxide and water? We oxidize the crap out of it, right? And we call that combustion. So this is basically just burning it, which is not useful in any sort of synthetic sense. But don't forget about that reaction. Remember, in the grand scheme of things, most hydrocarbons that we use, like gasoline, diesel, all that good stuff, we end up burning as fossil fuels. I hope you found this helpful. If you have questions, shoot me an email or write me something in Teams. Talk to you soon.